For this problem, we're going to try and integrate, but the first thing we notice is that the degree of the numerator is at least one more than the degree of the denominator. And so while we're going to use partial fractions on this eventually, we need the denominator to be of a higher degree than the numerator. Okay, so in this situation, whenever this happens, all you need to do is use either synthetic division or polynomial division to first reduce, in other words, find a factor, either linear or otherwise, to pull out to reduce this fraction. So our first step will be then to write x squared minus 2x minus 3. We're going to divide that into, and it just so happens that this numerator here has every decreasing power, but if like this x hadn't been here for a second, you would just plug in a 0x for the coefficient. But we have a 2x cubed minus 4x squared minus x minus 3. Synthetic division also works really well for this, if you remember how to do that. So I need to multiply x squared by something to get 2x cubed. So that means that 2x will work. 2x times 2x squared gives me a 2x cubed. 2x times negative 2x is a minus 4x squared. Okay. And then 2x times minus 3 is a minus 6x. Okay. Now we're subtracting. So since we're doing division, so 2x cubed minus 2x cubed, those reduce. I have a positive 4x squared adding to a negative 4x squared. So those are gone. And so I have then a minus, and a minus makes that a positive 6x minus x. So I get a 5x minus 3 as the remainder. Okay, and now you'll notice that 5x minus 3 is less than the x squared in the denominator. So we can rewrite this whole thing to x cubed minus 4x squared minus x minus 3 all over x squared minus 2x minus 3. We can write that as 2x, the quotient there, plus 5x minus 3 over x squared minus 2x minus 3. Okay. And so now this one we can integrate as is, but this one we notice that we can, the degree of the numerator is now one more than the degree of the denominator. Sorry, I said that backwards. Yeah. The degree of the numerator is one less than the degree of the denominator. Okay. So now we can use partial fractions on this term. So we'll focus on that part next and then put it all together and perform the integration. Okay. So we have 5x minus 3 over factoring 3x squared minus 2x minus 3. We get x minus 1. That's going to be a plus 1, and then an x minus 3. Does that work out? X squared minus 3x plus x. That's going to be minus 2x and then minus 1. Yep. Okay. Since these are both linear factors, we don't need to worry about any confounding problems there. So it's going to be x plus 1, b, and x minus 3. Okay. All right. And just like before, we're going to multiply everything through by this product. And so that's going to give us then the system of 5x minus 3 is equal to a x minus 3 plus b x plus 1. Okay. And just like before, since these terms can be zeroed out by an x value, I'm going to let x equal, let's say 3 to begin with. So it's going to give me 5 times 3 minus 3 is equal to, the a term will be zeroed out, and we're going to get left with b equals 3 plus 1. Okay. All right, let's see here. If I have a common 3 here, I can factor that out as 3, and this becomes 5 minus 1, which is really good because this bit right here is 4, and that means this bit right here is also 4. So the fourth will reduce, and b is equal to 3. Okay. So now that we know what b is, now we can use that, and the fact that we know that x equals, looks like a negative 1 will help us find what a is equal to. Okay, so we're going to get 5 times negative 1 minus 3 is equal to, again, the b term is going to be zeroed out, and so we're going to be left with a equals negative 1 minus 3. Okay. All right, this is negative 5 minus 3. That's going to give me a negative 8 there, equal to negative 4a. So it looks like a is going to be a positive 2. Okay. All right, so now we have our two coefficients, a and b, and we have, so I can rewrite this entire term now. In fact, I can rewrite it right here as 2x plus 2 over x plus 1 plus 3 over x minus 3. Okay, so I'm going to integrate each of these terms individually, and the first one will be really easy. It's just a power rule. These are both going to be u subs, where I'll let u equal the denominator. Since du and dx are linear here, there's not going to be any extra terms. So when I integrate this, I'm just get the natural log of the denominators, and then I can bring up these two as powers. And I can simplify it a little bit more if I wanted to, since this is the natural log, this would be products. I could write it as the sum. I could write it as a natural log of the products, but I will leave it in its expanded form. So this is going to be the integral of 2x dx. That's the first term, plus the integral, factoring out the 2, I get dx over x plus 1, plus 3, factoring out that term, 3 dx over x minus 3. Okay. Integrating these each, this is the exponent, add 1, divide by it, so this is x, so it'll be x squared divided by 2. 2 divided by 2 is going to be just x squared. This is going to be plus 2 times the natural log of absolute value of x plus 1 plus, and I could bring that up as a power of square and get rid of the absolute values because everything squared is positive, but I'll leave it as it is. And then I have, in this case, 3 times the natural log absolute value of x minus 3, okay, plus a constant. Like I said, I can simplify this a little bit more. I could pull this up as an exponent, pull that up as an exponent, and then write this as a product. But for the sake of simplicity, I'll just leave that as my final answer. Okay. All right, I hope that was helpful, and I'll see you in the next video.